The light bulbs that we grew up on produce light through heat. LEDs, or light-emitting diodes, they convert electricity directly into light. That's a big part of why they're so efficient. Well, invisible or infrared LEDs have been in our remote controls since the 1960s. The first visible LEDs were low intensity and limited to just red. It took another 10 years to get green and then yellow. So yeah, we had red, green, yellow, which of course became traffic lights by the 1980s. The point is that LEDs have been around for years, but only in certain colors. The big missing color was blue. Once we had blue, we could mix it with red and green to create white. Well, CREE was founded in 1987, and they brought the first blue LED to market in 1989. CREE recognized that solving the blue brightness issue would be a critical first step to mass market adoption of LEDs. And they've continued to innovate as they push the quality and the efficiency of their lights. And once that 100 lumens per watt barrier was surpassed, the stage was set for us all to start moving to the digital ceiling.
The genesis of CREE is quite interesting. When we first came out with the LED and we started talking about replacing the bulb, we were replacing the last vacuum tube. The transistor came about and revolutionized computing. There was still this last vacuum tube out there. And so in all of your ceilings you had that, and there was nothing much you did with that other than replace it on a regular basis.
An LED is a semiconductor device that emits light. If you look at the other technologies, talk about an incandescent bulb. An incandescent bulb really is the filament that you heat up until it glows. If you look at a fluorescent product, it's very similar in terms of, in this case, you're heating up a gas. That gas puts off a light that then illuminates a phosphor element inside the tube. And both of those tend to be inefficient compared to an LED technology.
I actually knew some of the founders when I was getting my PhD at NC State. They were material scientists and a couple of business guys that had the concept that if you could make blue light, you could make white light, you could do a lot of things with it. As we improved the efficiencies and the powers and got brighter and brighter blue, then you could start talking about converting that to white. And then once you started getting to 100 lumens per watt, people started to say and believe that you could start to use this in white light. All of our intellectual property-laden R&D is done on this site. This is our headquarters. We have about 1.5 million square feet of manufacturing space. We have teams working side by side with manufacturing style lines, 24/7. We're parallel to the production process, so we get real-time immediate feedback.
And that allows me to take that data then and look at productivity improvements for that space or enhanced user experiences. So one of the things that we do with our True White technology is the ability to add a yellowish white with a red, tune that on the black body curve and represent really a high quality light with the best color rendering index possible.
We actually have receptors in our eyes that recognize those different colors of light or different wavelengths. Artificial light essentially fools us into thinking it's daytime later than it is.
Severe Alzheimer's patients live in a world where, every minute is a new minute. So they don't recognize what time of day it is. They don't sleep well, they don't eat well because they just don't know what moment it is. And a lot of these patients will be housed in a typical traditional hospital where the fluorescent lighting is basically the same.
The circadian rhythms are essentially what regulate our body clock to let us know that it's time to go to sleep at night and time to wake up in the morning.
Well, they've now done studies where if you put in LED lighting with controls to mimic circadian rhythms or the time of day, their quality of life is drastically improved. It helps them sleep, it helps them eat. It opens up amazing possibilities where technology, again, meets people.
In the United States, approximately 20% of our electricity is used for lighting. In a commercial building, it's actually usually much higher than that.
As soon as you take out some of the wasted power that's being dumped into a room, it also improves some of the thermals and the HVAC management. So to get a LEED certification, you're trying to look not just at your energy consumption into your lights, but you're also trying to look at your energy consumption into your environmental. The minute you get controllability of that light beyond just on and off, dimming and occupancy and those types of things, you can add another 70% savings to just the lighting experience itself.
So that's really going to be the first step you're going to get out of these systems, is that additional energy savings that you're not going to get over traditional LED products. The next phase is going to be really then leveraging that connectivity.
Any sensor or receptor that exists today can be put into the digital platform.
We can now economically deploy a high-powered digital device that has integrated sensors, processing software, and networking essentially every 8 feet in a building. We don't see any other industry that has the ability to do that.
Light drives capability. The control of the light itself, it can be used to save you money, can provide health benefits, can provide educational benefits, can provide safety benefits. Solid-state lighting is the place where science and technology meet the human condition. It's the perfect interface.